one here. We'll catch the rest up later, hopefully. So we just to review last week's, we talked a little bit about cost estimation, and we did that exercise where we sort of guessed the president's of the university's salary and other things like that, just to give you some sort of idea, at least an experiential feeling of how difficult it is to estimate costs of things that you aren't day-to-day things that right? And the problem with all projects is you're kind of going into the future trying to wonder what is going on. And so obviously the more you have a better work breakdown structure, you might be able to that should help make the estimates, your smaller tasks. So you might be able to get a more accurate estimate of how long that's going to take and how much it might cost. But it does depend on sort of the sort of novelty, as it says here, novelty and risk, and sort of, how much effort you put into it. There's, you can spend a lot of money trying to get the accurate ones, but you have to decide. That's always an interesting question, is how much work do you do for how much accuracy? Where's the sort of place where it's diminishing returns? There's no sort of point being much more accurate if it's going to cost you a lot of money or a ton of work. So you just have to sort of estimate and go with that. So we looked at about 5 different ways to look at that, and sort of, orders of magnitude and rules of thumb. Maybe the most used one is sort of comparative. So sort of looking at historic and past projects, people can look at things and sort of say, yes, this is similar to the house that was built, down the street. So probably should cost about the same, or it's, 1.5 times as big. So we'll multiply it by 1.5, those kinds of things. Obviously, anytime you have purchase orders and contracts and stuff, you have a better idea. Although if you're the government, they seem to screw that one up too. Remember the COVID software that was supposed to be, I think, $500,000 ended up costing them somewhere north of 60 million. No one really talks about it too much because it's too sensitive, but I don't know what happened there, but people will probably go to jail, or they should anyways by the time that's over. And then of course, looking at, to help with that estimation is also looking at sensitivity analysis. So looking at sort of these triangular distributions that are shown here, whether you use a triangle or some kind of a PERT distribution. But the idea being, you sort of look at the high, the low, and sort of the mode, the most common one, and then try to figure out a sort of a median value that fits that. And if you have a more sophisticated system, and again, you have to ask whether or not it's worth the effort, but you can obviously model and add up a bunch of distributions together and get a final answer. The few times I've ever done this for projects, you end up with a answer. So it says, it's going to take, say, $10 million, but it ends up being plus or minus like $11 million. So it ends up being, the range is so wide by the time you've added up all these different ranges of tasks that it kind of, you sort of go, well, that's kind of a waste of calculations. So you have to be careful about that too, because these distributions tend to, make a big frigging mess. So that's that. So we talked about resource optimization too. We talked about the 2 kinds of resource optimization. The first being leveling, which is when things are on the critical path, and say, you are the project manager, and you obviously don't want to work 80 hours or a week, and so obviously you've got to somehow figure out how to level your time and spread it out so that you're sort of below the average hours. I don't know why this has 45 hours, but obviously some hardworking people, maybe that's what project managers are. But to level it and try to smooth it out like that. And then of course the other one is when it's not on the critical path, just to make it sort of smooth, so you're working about the same amount every day. So you don't have hard days and easy days. It kind of makes it try to make it level, and that's kind of more desirable. Doesn't have to be done, but the first one really is critical because you obviously can't work more hours than there are in a day or whatever. Although entrepreneurs seem to be forced to do that sometimes. And I think some of that is bad planning too. Then we talked about this, just kind of a summary of some of the things that you can do for your project. So this is, assuming sort of 2 weeks time or 200, 2 people or 2,000 people or whatever. And sort of the original sort of shows that, it's going to take, sort of 2 weeks to do the first one and 2 weeks to do the second. And, with these kind of resources. And obviously the things you can do is you can fast track it by trying to look for things that can be done in parallel. So obviously, a lot of that's done even to start, but there may be ways to fast track. Once you get into trouble, if your project's behind schedule, maybe there's things you can do in parallel. The one that I think I might have mentioned, but certainly we did, is when I was at Sanofi. One of the things they did was what they called filling at risk, and so we would fill the vaccine tubes from the big, huge, 2,000 liter tank before the stuff was fully tested, so that if it failed, we'd have to throw out not only the vaccine, which would be worth a couple of $1 million, but also all the glassware that we filled. Whereas if it passed, we'd be sort of ahead. So that's what fast tracking is. You're taking some extra risk by sort of doing 2 steps at one and then kind of waiting for the test. So this stuff would be filled, then it would be quarantined until the test came back. So we wouldn't make any mistake of shipping it. But that was what we sometimes did. And so there were certain products that we filled at risk all the time because they hardly ever failed. And the testing was very long. So if we had waited till the test was done, we'd sort of always be behind. So that's what they did. Obviously, crashing the schedule is what we sort of did in the demonstration in week 2, and that's by adding more costs or resources and shortening the time. Obviously, when you do things like leveling and smoothing, it's going to spread out the workload a bit and probably move up the time or the planning. So those are kind of important concepts to think about. So today we're going to talk about project evaluation and control, and a little bit on project termination and closeout. So the first one is my favorite subject because, like I said, when I started teaching this course, and when I did my PMP, my project management professional credentials, they have this on the exam all the time. And basically what they tell you to do is memorize these 3 facts, and just when they ask them to you, spit them out. And so no one understands this stuff, and people don't use it. And yet when I started looking at it to teach this course, I thought this is actually very useful and very valuable. So I kind of really got into it. And so hopefully my explanation tonight will help. The reading's okay, but not great. I've talked to the author about that already, but he hasn't really bitten on that one yet. So we'll see what happens. So here's sort of the control cycle. I think we showed this before. This is sort of the standard plan, do, act sort of cycle. You set a goal, you measure your progress, you compare your actual to your plan, and then you take corrective action. And this is a good segue to make me tell you about your interim reports. So I read all the interim reports that have been submitted. I think I posted them. I hope I did. And I think they're all pretty good, all interesting. People are moving along well. And so these are the kind of things that you have to do, right? Is measure your progress, compare to the plan, and then take corrective action. But everyone seems to be going well on those so far. And those who haven't handed them in, please do so as soon as you can, so I can do that. There's not a lot of marks or anything for this. It's just really an idea that you're kind of on track and going to somewhere so that you'll get a good final report that I can grade. And as far as the other one, the project plans, I've read a couple of those and made comments on them. I haven't graded them yet, so that's why I didn't post them yet. But I'm hoping to do more of that tomorrow and over the weekend. And so I will try to post, even if I don't get to the grading, I might post all the comments. I try to write comments on them. What I've found so far in the ones that I've looked at is that they're generally very good. They cover most of the aspects. I'd like to see a little bit more on the sort of maybe the financial sort of justifications and things like that. So I've sort of made some comments on that, but I think generally people are kind of covering it, and hopefully you got a chance to sort of think about all these different aspects of project management in that exercise, which is really the goal of it. So here's the plan, do, check act thing, which is sort of, it's really attributed to Deming. He's the famous sort of quality guy who was, but he actually claims that this guy before him, Short, kind of came up with the idea, so he passes that off to him, and obviously Toyota uses this as well. I was actually looking for cars, and I was at a Volvo dealer, and the lady who's the sales lady was had bought a Toyota for her mother because she was basically claiming that they're the best built cars. They have the longest sort of life and resale value of any car out there. Not necessarily that makes them the best, but they certainly are well built, and that's why they're number one, right? They really do this where they have every single employee, you know, is able to raise issues and sort of say, this, we could do this, we could do that to improve it. So they're on a continuous improvement sort of cycle that makes their production system the best in the world. Volvo used to, and I don't know if they did, I should ask the lady, but Volvo used to make their cars in teams. So they would have, instead of having an assembly line like all other car companies, they would have a team of whatever, 15, 20, 30 people, and they would each work on one car. And the idea was that would kind of be the reverse, would be more motivating because it was sort of, team number two's car, right? Sometimes if you buy clothes, in the old days when I bought suits, there used to be a little tag in the pocket and would say inspected by, inspector number 7. So they're kind of taking some ownership of it. So Volvo used to build cars that way. I don't know if they still do. So that's just an opposite kind of way to do it, but having more like agile, which we'll talk about next week. Sort of a team-based one. So here's a little bit about Edward Deming. He was the father of the quality movement, and basically was hugely influential in advancing the post-World War II Japan. He's really the guy who sort of built Japan into the industrial power. I mean, at least his theories did, and the Japanese were very receptive to all this sort of high quality, the Six Sigma you've heard of, and things like that. I don't think he invented Six Sigma, but he was certainly into the whole quality movement, sort of saying it's much easier to build it properly than try to inspect and throw out the bad ones, right? Make sure that everyone is good, which is really what Six Sigma is all about. So he's an interesting guy. My daughter is actually, who's doing her MBA right now, is actually has to read his book. So she bought it for me for Christmas, knowing that she'd have to use it in the course. Go figure, right? So here's sort of the PDCA cycle for so sort of applied to project management. I sort of made an attempt to look at that. So when you start with planning, you've got your work breakdown structure and your Gantt chart, and some costing, some cost estimates. And then the do is you're executing and you're tracking time, cost, and progress. And then obviously you analyze that data, the milestones, the Gantt, and what we're going to talk about today, the earned value management chart, and say, how are we doing against these goals? And then obviously you revise your forecast, you track your changes, you fast track or crash or do whatever you need to do to move the project forward. So the kind of, you can see how it kind of overlaps with the project management stuff that we're talking about. And this is just kind of a neat figure that I found somewhere, sort of, going through this sort of as you're moving up over time, you do that, go through that cycle, and then you sort of improve it, moves up to the next level as you're going on and on, getting closer and closer to more accurate estimates. And so these are the kind of things that you can use to monitor project performance. So we talked about in the quick write, the S curve, and I'll mention that in the next couple slides. Sort of, just looking at the sort of budget over time. You can look at milestones. So this is quite a common method, and sort of some of it sort of developed by what's the guy's name? I just read his book this summer. He's an emeritus prophet, McMaster. Shoot, I have his book here somewhere in this wet mess. Where is it? Oh, here it is. The guy's name is, no, that's not it. It's going to be an avalanche. No, that's not good. Whatever. Oh, Cooper. Cooper's his name. Robert Cooper. But his whole idea is of having gates, and so there's set periods of time where you look and say, where are we? Should we cancel the project? Should we continue it? What kind of decision needs to be made? So that's what milestones are for. You sort of have major events. I mean, what we talked about before with Elon Musk was he sort of had a milestone that he had enough money to sort of do 4 rocket launches, and if the fourth one didn't work, then I think SpaceX would have died. But fortunately, the fourth one did work, and so SpaceX was able to secure, NASA contracts and things like that, and the rest is sort of history, right? And then obviously the other thing you can do is a tracking Gantt. So you have a Gantt chart, but then with color codes, they can show the original Gantt chart and then a new Gantt chart sort of overlaid on it with a different color, showing how the different tasks have gone a little bit longer or a little bit shorter. And so how it sort of shows, it's almost like overlaying the current Gantt with the original Gantt and sort of showing over each other how they're doing, seeing if it's getting longer or if you're really lucky, shorter. So those are the kinds of techniques you can use. Um, so here's just a couple of examples of the S-curve. You can see that the S-curve comes really from a probability distribution. If you take a probability distribution and you add up each bar cumulatively, you end up with an S-curve, right? It's the same sort of thing. And what that sort of shows, if you look at the time, is starting a project is kind of slow as the team kind of gets together and gets organized. I'm sure you've had this kind of experience, even doing your homework on your own or your assignments that I give you. It's sort of slow to start. You kind of got to get into it. You got to get into the right mode. Then hopefully in the middle, you're sort of highly productive. And then the very end is also slow because you're doing the sort of nitpicky things like spell checking and checking references and all these sorts of things that are, just kind of shouldn't take long, but they seem to. So the sort of productivity goes a lot slower at the end. So it ends up sort of generating this sort of S curve. I actually, for the, what I did when I put up on the web my little project learning thing on EVM and other things. If you want to read that, I sent an email saying you could. And I actually spell checked that with Grammarly. It was fantastic, but it found like 200 errors, small things, but it's a really cool piece of software for, I don't know, 50 or 60 bucks a year to review all your sort of writing and kind of give you suggestions. And then you can obviously turn them down if you don't like, if your style is a little different than Grammarly. Sometimes it kind of, because it's AI, it kind of goes off track once in a while. It doesn't quite understand what you're trying to say, but maybe you don't either. So it may be a sign. Um, on the other side, we sort of see the start of two different kind of versions of the same graph, where you see, time on the x-axis and dollars on the y-axis. And you can sort of see we've got in the top one, you have a plan. So you've sort of figured this is what our spending is going to be month over month based on the milestones and tasks. And then you can track actual costs against that, how much money you spend, and sort of see whether you're over or under budget, right? So that's the kind of thing. And we're going to get into that in much more detail in a minute. And then here's milestone analysis. And basically having a bunch of different milestones over time and major checkpoints. Maybe you have project phases. The bottom one is kind of one of these sort of standard, templates you can buy to use with PowerPoint, so you can make all these names and tasks. And a couple of you did something similar to this in your project plan, sort of a milestone based kind of thing. Here's the major tasks that are going to happen over the particular time. So these are the kinds of things you can do with milestones. Certainly venture capitalists use milestones a lot. A lot of the legal contracts, we say, if you can do this by a certain date, then we'll give you more money. And if you don't say we won't give you more money, but it kind of opens up the negotiation. So then you can be nasty to the company and say, we'll give you more money, but we want more percentage of the company, or we'll give you less until you get the work done. You can do all sorts of things. But as long as you hit the milestones, then all this money is given, continues to flow. So we call those tranches. So you're saying, I'm going to give you $5 million, but it's in, $1.25 million tranches based on you achieving these 3 or 4 milestones as you go along, right? And so that's a lot of the time how we do that. And I can tell stories about how that worked and how that didn't work at different times, but we'll leave that to another day. So here's a tracking Gantt. So you can sort of see a normal Gantt chart, and then you can see the two colors or the little bar inside the colors sort of showing how that little bar is moving relative to the base plan, which is the big boxes. So you can sort of see in the case of homepage, the second one, John's a little bit behind where the bar should be. You see the little green dotted thing. Hopefully you can see that. It's pretty small, but you can sort of see it's a little bit behind schedule. So you can see that this lots of different ways to do this, but sort of overlaying two Gantt charts on each other. That's a really useful way because again, Gantt charts are really the best way to look at things. They have a lot of information, but really easy to digest. So tracking Gantt is a good way to go. And the software all does this generally pretty well. You can see that the two columns is the estimated hours, which is the plan, and then the actual hours. And so then you can see with all that data, the computer can draw all these different bars and all the differences. Okay, so first question, what are the 4 components of a completed task? Give you 30 seconds for that one. We got our normal 12 out of 19 people. Good. Should say I just learned that I'm teaching this course in the fall. So if you have any of your peers that are interested in project management and of course you would recommend the course, then I highly encourage you to do so. If you don't recommend it, then don't say anything. Okay. 3, 2, 1. What do we have? Yeah, we have deliverables. Anyone else? Documentation. Notify stakeholders. That's good too. Approvals. Think about my little formula. What kind of things does a task have? These are all good, but perhaps the question's a little bit vague. So absolutely getting approvals at the end of maybe not a task, but certainly at a milestone that you reach to a certain point and you have some customer, whatever that means, feedback or stakeholder feedback. Let me show you where I was trying to go with this question. So these are the things that a task has. It has originally a task has a plan cost and a plan time based on that kind of little equation. And then in actual fact, it has an actual cost and an actual time, right? So the actual time is very easy, and so are the actual costs. You just add up all the invoices you have. So, whereas the plan ones are obviously the different. So those are the sort of 4 things that I was looking for: the plan cost and time, and the actual cost and time. And we're going to talk about earned value management. So it's a way to, this is long and wordy, but it's a way to give you a picture of how your task is doing on those 4 aspects. And it includes all 4. The difference is that Gantt charts, although you can put costs in them and they can kind of appear there and you can manage the columns, it doesn't really visually display costs very well. It's mostly a time-based sort of structure so that costs are sort of missing. And that's why when I really understood what EVM diagrams were about, as opposed to just having to memorize it for my PMP, I thought this is really a good thing that really needs to be added to the toolbox of project management tools. So So it measures the amount of work. Okay, so when you're completing work, you can have, there's lots of choices, right? You can estimate. So let's say just a particular task. So let's say your task is to, write a first draft of your project charter. So you can decide many ways to put that on a Gantt chart. You can say it's either 0 or 100. So it's either you haven't started it or you've finished it. Like there's nothing in between, right? So even if you've done 10% of it, that kind of falls back to 0. Basically, it's either done or it's not done, right? That's one way. The other way is sort of 50-50 and sort of say, well, if you've done it, we're going to assign 50% to it. And we're just going to say every task, because on average, if you have 1,000 tasks, on average, they'll all be the averages that be half done, right? It's the old kind of rule, which it's one of those weird statistical things that I don't really get. But if you're waiting for a bus, a random bus that arrives at a random time, not at fixed intervals, the amount of time that you've waited already is about the amount of time it's going to take for it to come. And the idea is because on average, the bus is halfway from your stop from the last stop, right? So it's a bit of a weird concept. It's one of those strange stats things, but it is true, but it's kind of hard to comprehend. But that's the idea. So the idea of 50 is basically anytime once you've started a task, you declare it's 50% done, even if it's 99% done or if it's 1% done, because on average that averages to 50. So that's the 50. The third one is 0, 50, 100. So that's kind of a little bit more breakdown where you say it's either not started, it's either done, or it's kind of in the middle, right? So if it's 5 or 10% started, you'd say that's 0. If it's 50 or 60, you'd sort of say 50, or 40 to 60, 60, 70. And if it's kind of 90 to 100, you'd say it's done. And then the last one is to have the actual estimation. So you sort of say, yeah, I don't know, I think I'm probably about 35% of the way through. So those are the four. And the question really is, what are the pros and cons of these different methods? And so just pick one and tell me, write down the method, and then list the pro and con of that one particular method, whether it's 0, 10, 50, or 0, 50, 100, or actual. So I'll give you about a minute for that because it takes a little bit of thinking, 40 seconds. Like most things, I believe there's no real right or wrong. There are always advantages and disadvantages of each of these methods. And so every one of these is used by different groups. Whoops, I'm getting ahead of myself. Okay, let's go 3, 2, 1. Any ideas? Okay, 0, 100, simple, but lack of detail. Absolutely. So it's either started or done. Very simple. But you're right, not a true picture, as someone else said. These are good answers. Not very time consuming. That's also good. You don't have to fight over, with other people saying, did you start it? Did you not? Um, let's say 0, 50, 100 pros, difficult to keep track. That may be the case too for that one, but it does it's a little bit fairer, if you want to say that, or clearer. So you can do that. What about, so those are all good. What about actual? What are pros and cons of actual? Someone just can type that in. Of an actual, of an estimation, I guess. So it's really not an actual, but yeah, so it's hard to estimate. And so that's good, Natalie. Thank you. It's very hard to estimate so that it's not necessarily accurate. And the thing is, it also leads to a bit of gamesmanship too, right? So, you go to a meeting and everyone says that their project is like 90% done. Don't worry, it'll be finished tomorrow, right? And of course, that's not true. So, this other way kind of becomes, these other three methods become very clear. It's either, it either is or it isn't, and you can sort of even an independent person could look at the project and what's going on and say, well, clearly that's not 100. Clearly that's not 0, but you've done a fair amount, so let's give it 50. Or they just say, it's not done, it's 0, so forget it. So actual is very difficult because people start coming up with weird things, and we've already done that last week with the predictions that, getting accurate numbers is hard, so why are we wasting our time doing such detailed stuff? So a lot of these people use these techniques, and I got some slides out of the order, but here's one. Here's an example that I did, and I actually just did this last week. I thought about it more carefully. Obviously, one of the things to do is to track more often smaller tasks. But if you notice these things, depending on the completion estimates, basically, if it's 0, 100, it's always the most pessimistic, right? Because no matter, if you've got a task half done, you're going to assign it 0. So that's always going to give the worst number. The 0, 50, 100 kind of gives you the mid-range, and actual is can be the most optimistic. So if you got 2% of it done, or if you got 99% of it done, then you're going to get 99 out of 100, whereas the other ones aren't going to give you that. They're only going to give you 50 or 0. But if it's 45% done, of course, you're going to be a little bit lower. The 50% one gives the sort of most optimistic. So you have to decide. You can see this was just on a particular case that I had in the book chapter that I was writing, but you can sort of see that they're fairly close on this one. This was kind of a late stage project. They're sort of within 10, 15% of each other. But again, you can just decide maybe based on sort of historic sort of things and say people are always being, over optimistic. We're going to go with a mid-range estimate or a more pessimistic one so that we don't over forecast and kind of start promising the customers that things are going to be done before they do. So that was kind of why I did that. So let's go back to this one. So what does this figure show? I'll give you if just any kind of comments, you can just chat them in. We won't do the countdown, but what does this figure show? What's a fact that you see on this figure? I made all these little weird colored bars just to sort of show you how they line up, but I don't know, it's getting kind of goofy when I started doing that. So what does this figure show you? If no one knows, that's all right. We'll move on to explaining it, and then you'll be an expert at it, and I'll bring it up again later. Yeah, so you're comparing the metrics, right? So you're comparing the cost to the plan to what you actually did, right? So you are comparing those sorts of three things in a sort of financial way, and I will kind of break down how that actually works. But what it basically shows is the green one is the plan. So that's the original sort of S curve that you started with. The red one is pretty simple because that's the actual cost. So you just track costs over time, and that's what it looks like. The earned value is the complicated one, and that's what we're going to explain in the next few slides. But I think first I have a video that's going to explain some of it, hopefully, and I'll explain more. Oh, you know what? I got to wait a second. I got to stop the share. I got to do that thing again when I do it properly. Share screen. I always forget to click these. I don't actually know what they do, but let's assume they help.
Value management is a project management technique to measure project performance and progress by examining the work completed at each stage of the project. In simple terms, here's how it works. Every project has a planned cost, which is the amount of money that the project is expected to cost, a schedule, the amount of time that the project should take, and a scope, the amount of work needed to be done in order to complete the project. Let's say the planned cost for your project is $10,000. The schedule is 3 months and there are 100 estimated hours to complete the work within the scope. As the project progresses, so does cost of salaries, expenses, and so on. This is the actual cost. Now let's say you're halfway through the project timeframe and you've spent $4,000. If we only take a look at these two numbers, it would seem clear that the project is slightly under budget and doing well. But what if we take into account the amount of work completed? Here's how we can calculate what EVM calls the earned value, or EV for short. As the name suggests, earned value is simply the value of work done at each stage of the project. Let's say that although you're 50% through the project timeline, you finished 25% of the work within the project scope, or in this case, 25 hours. A simple formula allows you to calculate the earned value, EV equals PC times number of completed hours divided by hours within the project scope. So in this case, earned value equals $10,000 multiplied by 25 and divided by 100. This gives us $2,500 as the earned value at this moment in time. If you're working within agile methodologies, this would be the burn-up chart status, and whatever is remaining in the project scope is the remaining backlog. You can now see that although you've spent less than 50% of the planned cost of the project, you're behind in terms of progress. The difference between the earned value and the planned cost gives you the schedule variance. The difference between the actual cost spent to date and planned cost gives you the cost variance. With this in mind, you can assume that the rest of your project will continue in this manner, and if nothing changes, you will be behind schedule and over budget. Knowing this information early in the project allows you to be agile and make changes where needed before things get out of hand. And that's EVM in a nutshell. Try Tempo budgets and get Agile EVM seamlessly integrated in Jira. Go to tempo.io/try.
So you see that last thing he was talking about was basically, crashing the schedule to get it back on track. So you can see how this EV thing is kind of complicated. It has these formulas and it gets worse. So I tried to understand it first and then try to simplify it. And so the first thing really to talk about is just S curves, which we talked about before. And sort of this whole EVM is based on these sort of S curves, these three that you saw. And, that's sort of the basis of it. It's supposed to be easy to read and look at once you actually understand it, but it's a little bit harder to actually do the calculations and figure it out. It's not as bad as you think, but just takes a little bit of playing with it to kind of learn. So I showed that already. So here are the three sorts of curves. So the planned value, so that's sort of, they have lots of different terms and they show all these equations, and I'm going to try to avoid most of them and try to do it graphically. But basically the plan is really what you plan to spend over time. So it's a curve right from the start. It's your forecast one. So that's the green line. Then you have your actual cost. So that's pretty easy. You just look at any day and you plot how much money you've spent and you add a cumulative cost and so you can plot that. So that's pretty interesting. The one that's weird, which he talked about, is this earned value, or it's also called the budgeted cost of work performed. Again, your final exam is open book, so you're not going to have to figure all these things out and figure out which term is which and all that kind of stuff. Hopefully you'll conceptually understand what's going on and you can read these graphs. But basically what happens is that is how much of the work you've actually done. So just think about earned value as how much work you've actually done, kind of more on a work basis more than a cost basis. Even though it has a dollar value, that's what kind of makes it confusing. So then at the very end of a project, you obviously have a budget at completion. So that's what you plan to do at the end. And then you have the two other things, which is you have the estimated cost at completion, and the estimated date at completion, right? So again, the budget has a time, is the planned time, and these are the four things. The budget has the time, planned time and cost, and then the actual has what really happened at the end, both in cost and budget, right? So that's the two different things. And obviously, these are estimates because we're trying to use this as a tool to forecast the future. Well, okay, so now that I've fully confused you, hopefully I'm going to work through this on some diagrams, and that will make it a little bit easier to follow. So here's the first one. So this is the plan, cost, and time. So since the quality and scope is cost times time, this is basically what you're drawing. So here's time, and there's the dollars. And, you expect the first month you're going to spend $100,000. The next month you're going to spend another 100, or, and then you're going to finish up. by the time you spent, you know, $1 million, the project's done. So that's your plan. That's pretty straightforward, I hope. And then we get sort of these things at any one time. So that's the data date, which is that bar you see with the 3 dots on it. You can see that basically that's where we are in plan. We should be, you know, what has happened in the past is a fact. What's going on in the future is an estimate. And you can see in the past, we spent this much money, the red. We spent more money than planned. And then the earned value, which is how much progress we've made, is actually below the plan. So we've spent more money than we should have, and we've got less done than we should have, right? Is what this diagram is showing. So this is at a given time, that this is the data date. So you can look at any time and you see, and then what you can do, of course, is measure the difference, right? So the difference between how much money you spent and how much money you should have spent to get that many milestones done is this bar. And so you can see that we basically spent, if you believe my math, about 3 times the money than you should have, right? To get to this point. So you're kind of obviously way over budget, and that's why the actual cost line is so high. Then we could also look, so that's the cost. So we remember we're talking about time and cost. So on the other one, we have versus schedule. And so again, there's 2 ways to do this. And this is what you had to memorize for the PMP that I didn't make any sense. But if you look at the vertical bar, what's it's basically saying is this is the difference in dollars between what you should have spent to get to this point and what you did spend. And that kind of doesn't make any sense. So what I kind of developed is if you look at the horizontal bar and kind of look where the earned value would have hit the plan, that's how much work you actually got done. So you can sort of see that we're behind by a certain number of months, whatever the time scale is there, which is the bar going the other way. We're basically, we've only done about half the work that we should have, right? At that point, we're about halfway over the time, right? So we're halfway behind. We spent twice as much time, and we've spent about double the budget. So this is a project's kind of going off the rails. Does that make sense? And from a show of hands, of people following this, or should I try it again? Are we doing all right? So obviously the most important thing is really these 2, right? So the vertical bar is sort of the cost. So we're looking at where this particular point in time, we are, you know, 3 times, we spent 3 times as much money as we should have. And we're about, we've only done about half of what we should have done. And we're, you know, 2 times unfavorable in the schedule. So that's what it sort of shows, right? That's what these graphs show. And so then, of course, what's useful is not only that you're behind and thing, but you can also do some forecasting. So you can take your Gantt charts and your cost estimates going forward and look at where you might end up. And so here's sort of the plan. And you can sort of see I just extrapolated the lines going forward, but you could do this on the data that you have. And you find out that, of course, if you look at the blue compared to the green, so you look at the earned value relative to the plan value, you can see that they're at the same level because the project is done, but we're certainly past the time. So this project is going to be late. And then if you look at the other one, the actual cost compared to the plan, you can see on the vertical side, you can see that we're obviously over budget, right? And so it forms a little square between the plan value, the earned value, and the actual cost. They always form a little square. And of course, you have to believe me, this is not in any textbook I've seen ever, but basically you can arrange those 3 colored dots any which way you want to form 4 different kinds of squares. And I'm going to show you about that in a minute. But let's go to the next one. So here's what we did before. So you can see the original one, and then you can see the final. And you can see the final, we're behind time, but now we're only behind time by 1.2 times. So we caught up a little bit. And you can see that we are behind on spending by about 1.3 times. So 30% overspent. So we've done a little bit of work to catch up, but you can still see we're over budget and behind time, which is a typical project. And that's why I put a kind of a red star there saying this is sort of bad, we're behind time and over expenditure. But you can see sort of by predicting out, we can sort of see this. So this is the kind of graph you would give to someone and sort of say, this is what we forecast, and this is where we're going. So obviously it's got actuals up to the data date, and then the estimates going forward say, when we finish, we expect to be late by 20% and overspent by 30%, right? By doing just the math on this without any numbers on this sheet. So that's what it looks like. And in actual fact, it looks more like this. And this is, so you can see I started to label all these little things, the earned value at completion, the schedule at completion, the budget at completion, and things like that. So these are all these terms, but I'm not going to get too deep into all of those at the moment. But you can sort of see the real difference is that we have the earned value kind of in steps. And I'm going to answer this question. I'll spare you the thinking about it. But really, the reason this is more accurate is this is how it's going to, this is how earned value is going to be. It's, you know, costs are very continuous. You could look at your costs every hour. You could ask the accountant, you know, if another bill came in, or you could look on a daily or weekly basis. It would be a relatively, you know, smooth curve. There might be some bumps if you suddenly had a big major expenditure. Your plan would probably be fairly smooth, but your earned value, you're going to sort of say, again, it's sort of going back to that, you know, 0-100 or 0-50-100 sort of thing. You know, are we done? Are we not done? And so you're going to kind of get more of a sort of steppy kind of looking diagram, as opposed to, you know, obviously if you have a big diagram, it'll smooth out into a curve. It is effectively a curve, but it's just got a sort of, it's more integer than it is sort of a continuous sort of thing. So that's why this one's a little bit more accurate of what they actually look like. But you can sort of see forecasting future forward of how you think, you know, as each task gets done. So here's just, I'll skip this one. Just it just has some more definitions of all these sorts of things. It's the same diagram, but they've just labeled all the different things so you can look at them. And so obviously there's lots of different things. So you can see the actual cost curve, the plan curve, and the earned value curve. I tried to keep the colors relatively the same all the way through to make it sort of easy. And you can sort of see again, it shows the SV at T is the schedule variance for time. And then there's a schedule variance dollars. It's just looking at it a different way, but the time one makes more sense, I think, because people really want to know how much are we behind budget and how much time are we behind. The weird thing about EVM is it has this thing called schedule variance, but in dollars. And so you say like, yeah, we're behind the schedule by $2,000. People kind of go, what? It's true, but it doesn't really mean anything. It's much easier to say we're behind by, you know, 2 months or 3 months or half the time of the project or something, right? So that's, I think, one of the kind of insights I had when I was looking at this, sort of saying it's got to be explained better than this, because this SV dollars is just a very strange concept that you have a, you know, it's true, but it's just something that, you know, it just doesn't make a hell of a lot of, it's not easy to sort of comprehend. Okay, yeah, we're behind budget by $1 million and behind schedule by $500,000. Well, whatever. Whereas you say we're behind budget by $1 million and behind schedule by a month, you can kind of go, okay, can we make that month up or not? And go forward. So that's just the sort of definitions. This one I was looking at again, and I'm thinking, what am I showing? But what this does show, the one thing is there's a sort of, at the very top, you see that yellow bar, that's sort of a management reserve. So they actually sort of plan to this budget at completion. So this is the where the green line goes, but they actually have kind of a little reserve on the top. So that's what this shows. There's a lot of other things on here that kind of make it sort of messy. I had to redraw the colors so that they'd be consistent for that. So we'll skip that one for now, or not look at it too long. But obviously you can't build in a management reserve. So here's our budget, but here's our contingency. So if it kind of creeps up to that, into that light green area, that'll still be all right because you've planned for that. So what I said obviously is, if I go back to this one, you can see that these three dots make a box. And the box can be, there's 4 different boxes. You'll have to just believe me for now, and then you'll see when you kind of look at it. But there's 4 ways you can do this. You can obviously be ahead or behind schedule, and you can be over or under budget, right? So 2 by 2, you get 4 boxes. So let's look at those boxes. So here's what they look like. Don't worry about all the text, but you can sort of, if you look at the drawing in the corner, obviously you can be ahead or behind schedule. You can be over or under budget. So if you're under budget and ahead of schedule, that's great, right? That's fantastic. If you are over budget and behind schedule, that is bad. So that's why I colored it red. If you are under budget but behind schedule, then perhaps what you could consider doing is crash the schedule. You have some more money, so you could hire a couple more people and try to get back on schedule, or hire another piece of equipment, right? And then the worst is perhaps, or not the worst, but the other 4th box is this one where you're over budget, but you're ahead of schedule. So you're kind of, you've done a good job, you're ahead of schedule. So maybe you can slow down. Maybe you can, hire, not use the most expensive equipment because you've got extra time, so you can do things a little bit slower, a little bit more efficiently. And so that's the sort of save. So I kind of colored it lightly green, and I called the crash lightly red, but really the obvious ones are the good and bad. The ones in between are kind of debatable, right? Whether you're either looking for savings or you're trying to crash the schedule, right? So if you want to get back onto sort of somewhere near the middle of that of those boxes. Does that make sense so far? This always worries me, but because I try to explain it, and it's a bit difficult. So here are the 4 scenarios. So this is kind of what I did. So in the top one, you can see, so you can see in all 4, if you look at them, the dots, and the EV is actually yellow, not blue, because I've got a blue background, so I had to kind of change the color. But you can sort of see that the 3 dots are always in different places for these, but they're always in 3 corners of a square somewhere or other. And so in the top one, you can, and I obviously color coded them to fit with the pattern. So you can see in the first one, the PV, so the plan value is the green one. So you can see that the earned value was before the plan value. So that means you save time. So you were under schedule. You were under schedule, but you can see that the spending was higher than the plan. So you're over budget and ahead of schedule. So that's sort of the light green, and that's why that square is there. The bottom one, of course, you can see that the plan value is in the top corner. So that means you're behind schedule and under. So that's the best. You're under budget and behind schedule. And then likewise, the top other one, this is the most common one, of course, which is what I showed already, which is your plan value. The earned value was later and the cost is higher. So obviously that's the negative one. So you're behind both budget and schedule. And then the 4th one is the one where you're behind schedule and under cost. You see the cost being the pink line or red line is lower, right, than the original plan. So you did it under budget, but you're still late. So again, that's, again, depending on what you talk to your manager and decided which way you want to go, those are things. So just a quick show of hands, does that mostly make sense? I hope. Yeah. It is a little bit tricky, and if you want to actually know how to do it and make the kind of measurements, it's not that complicated, but my 30-page chapter or whatever on EVM that I posted and spell checked with Grammarly is there. But let's go to one example, one that we know well. And of course, this would be the Sydney Opera House. So you can see the green was the plan value. So the plan value was 4 years and 7 million Australian dollars, right? So that was what what we talked about in the event. You can see, so that's what it was, and you can, I kind of drew a quasi S curve there, right? Then you can sort of see the actual costs. Obviously, they incurred costs for the whole however many, how many, it's 15 years or whatever. No, 12, 13, 14 years. So for the whole 14 years, they kept on spending more and more money, up to 102 million at the end. So you can see they went way past the original $4 million, or the original $7 million budget, all the way up to 102 million. So that's an actual cost, and it fits with the time and the cost. So that's kind of a fact. But then the earned value, obviously the earned value has to end up at the same 7 million, because that's what the original forecast was. But you can sort of see that it took much longer to do. So you can sort of see, again, there's a big square here, with the present value, the earned value being way later. So that means it's way behind schedule, and the accounting cost way higher than the planned value, so way more expensive. So the answer to this one is that square is huge, and so it's a really bad project, because it ended up being 14.5 times over budget and 3.5 times over time of the original forecast, right? So that sort of shows you that final square. So if I go back just a couple, you sort of see, normally I make the squares relatively small, just for example purposes, but in actual fact, this square is bigger than the rest of the graph, because they're so far behind and so overspent. So hopefully that makes that relatively clear. Is there any questions on that? It's a it's a really useful, like if we go back to not that one, something like this, if well, maybe not even with the stars, but you can put the stars on, forget the even something like this. If you show this to a manager and who's actually, it takes a little bit of training. So it's not like, again, it's not inherently intuitive right off the start. But if you sort of understand this and look at this, you can sort of say, oh, I see this. I see where we are. And I see kind of where the forecast is going, that, if we keep on going on the same sort of tact, we're going to end up, months behind and way over budget. So can we do something to fix either of these things? Or should we report to our boss or whoever that, this is the reality, that, things are not, the plan was a little too over aggressive, and now this is what we expect to happen. So again, you can sort of do these sorts of visioning. So let's see where we go on. So I'll get back to my famous Sydney thing. So you can sort of see. So a couple of facts here is that if you look at these squares, the EV and the account and the actual cost always are on the same vertical, and the plan value and the EV are always on the same horizontal. No matter which way you draw the squares, you can see the yellow and green are always on the same vertical. They're in different, two of them are low, two of them are high. And you can see that the pink and yellow, or red and yellow, are always on the same vertical, either far over or on this side, right? So that, again, 2 by 2, you get the 4 different options. So this is really the most important sort of slide to kind of show you the different final outcomes, right, of the thing. And you can sort of see, in the second one, you can see that, again, the actual costs were over for a while than the plan value, but then they got back on track, and so it ended up finishing under budget, right? So again, just the way that I drew the curves. So the curves can cross each other, and I'll show you examples of that in a minute. How are we doing for time? So maybe we should take a 10-minute break right now. I just stop on these disasters. This is just a reminder that we're kind of in the middle of the talk. So the first one's the Tacoma Bridge. The second one is the Apollo 13, and the third one, of course, is the Fuji, whatever it is, Fukushima Daiichi reactor after the tsunami, right? So these are the kind of um, project disasters we talked about before. But I was wondering why this slide was in here when I was reviewing these slides on the weekend, and then I realized it's just sort of the break between the two. So let's take a 10-minute break right now, and then we'll be back to finish off sort of the EVM stuff. I've got some stuff on some of the formulas and things that, again, you don't really need to know. I just want you to be able to interpret the graph. If you want to learn how to draw them, then I recommend you kind of do it's about an hour to go through my 36-page little exercises to really get to be a hardcore EVMer. It took me probably 2 or 3 weeks to sort of sort it all out and make sure that it all added up and made sense. But I'll go back to this one just so that anyone who is just sitting around wants to look at it can think about this and sort of see why these are the four different choices, being over or under budget, behind or ahead of schedule, how these things kind of the curves end up in these different combinations. So let's take 10 minutes, and so we'll be back at 1:45, and we'll finish up tonight's lecture then. Okay, any questions? I'll get another Gatorade. Good, I'll be back in a few seconds, and if you have questions, I can answer them then. And wait, hopefully you're all back. So here's just another. I realized that that slide I showed before is the same slide, but it's off axis and it's got all some of the old data on as well. You can see how I'm tried to draw over this with the management reserve. But again, you can sort of see that the oops. You can see that the the actual cost in this one is higher than the plan, and it's even higher than the management reserve, and that the schedule is later. The estimated completion is later than the planned completion. So again, this gives you my designation as of the bad, the red, behind budget and behind plan. Okay, try not to get too scared of this next slide. So here's some of the calculations. And basically they're fairly straightforward. Again, I'm not going to make you do calculations, but basically the cost variance is the actual cost minus the earned value. And so obviously if the actual cost is higher than the earned value, then it's unfavorable. I like the terms, and I don't know what you learned in your accounting courses that you've taken, but I like the terms favorable and unfavorable. I don't really like positive and negative because it all depends on what kind of rules you're using. So unfavorable, means that it's, obviously you're overspent, and favorable means you're underspent. So I like unfavorable and favorable. And so you can see the same thing. The schedule variance is the difference between the plan variance and the earned value. And again, if it's positive, if the plan value is less than the earned value, then it's also, wait a second, does that make sense? Plan value minus the earned value is positive, then the plan value is greater than the earned value and is unfavorable. There's a typo in that one. I'll have to fix that. Let me write that down. Um, and so then they have some other things. They do cost performance index, so that they just looking at ratios of the earned value to the actual cost. So again, sort of seeing what percentage you're over or under. And you obviously can do the same thing with the schedule performance index, looking at the ratio of how far you've spent relative to, or how far behind you are relative to where the plan was. And we already talked about those decisions about how you're going to pick which task you're on. Here's some more formulas. Again, we're not going to go into a lot of detail. I just want to be for completeness, but the value at completion is the budget at completion. The variance at completion is the budget at completion minus the earned value at completion, right? Obviously, so you look at where you actually ended up relative to the budget. You can also do ratios of those too. And the last one is this sort of this to complete performance index is really looking at whether or not you have enough funds or time to complete the budget. So you can do those kind of calculations too. But I think the formulas are what they kind of make you learn for the PMP, but in actual fact, I think the visuals are much more useful, and that's why I support that. Okay, so we'll get back to that. We got some more examples in a minute, but how can we estimate the time and cost going forward? So let me give you a minute for that one, or 45 seconds. So let's say we're at this famous data date. How can we estimate the time and cost going forward? If we all entering, so let's do 3, 2, 1, see what people have come up with. Yeah, so you can assume the future work can be done at budgeted rate. You can look at the previous information, which I think really means sort of using the current rate, even though if we're behind already and we're working at 80%, we can probably forecast that we're going to be 80% behind for the stuff that's left too. So, but just sort of extrapolating out at that poor rate. So I think that's the kind of thing that you're getting to, comparing to the initial plan. So that's excellent. So that's exactly what the answers that I have are. So let's go to this one. So here, first of all, we're looking at this cost performance index and the schedule performance index. So basically, those are the ratios of how far ahead or behind you are in both cost and schedule, right? That's what we're talking about here. So, you could have systematic errors. So just your forecasting, you just weren't a good forecaster. You were overly optimistic, the sort of planning fallacy we talked about before. Or you under forecast because you were sort of padding the budget, or you just kind of made just general, errors and things. And then the other one could be consequential errors. So there could be, sort of some kind of one-time event or some serious setback that really screwed up the project in one place. Piece of equipment wasn't available. Someone got sick or everyone got COVID or something like that. So these kind of things that, no forecasting really could plan for, one of these, serious impacting risks, but very low probability. So you have some of those that you've decided, you're not going to worry about. You have a tsunami, obviously, you've got a serious consequential error. So, the things you can do to improve this, of course, is you can modify the scope. So depending on if you're above or below budget and time, you can obviously reduce what you're going to get done and sort of say, we're not going to add all these bells and whistles. We're just going to go for the basic version that works, which is certainly one thing to do. You could obviously expand the scope if you have more time and money. Not really recommended, probably better to get the first one out. You could do sort of improvements. So obviously things like schedule crashing that we talked about and that we demonstrated in week 2, or doing the cost savings we saw on the other square on the under budget, ahead of schedule, or over budget, under budget. What am I trying to say? Over budget and ahead of schedule. So just sort of do cost savings and try to get, use those cost savings to get back on track. And then the last thing we can do is rebaseline, is basically say, and again, we talked about sunk costs last week or the week before. We can say, forget what's happened to date. Let's pretend it's a new project starting from whatever's been done today, and let's just replan. And that's the question I always have about the Sydney Olympics, whether they rebaselined a few times, probably sort of saying, geez, we didn't really realize that those shells were going to be so difficult to make. So now we've changed the plan. Instead of being a $7 million budget, we're going to make it a $40 million budget. And then, as they went along and they said, oh, geez, we had another problem. We didn't realize the inside acoustics were so complicated. Instead of being a $40 million budget, we're going to make it a $100 million budget. And then, they may have finished the project only $7 million, over the rebaseline budget. It's not, you can say it's cheating, but it's also a decision process to sort of say, geez, we'll reset the budget. We all know, I mean, you can still compare the thing to the original plan and say, geez, we missed by a mile. Why did we do that? What can we learn? But the rebaselining says, from here on, now that we know that these problems exist, what's a good estimate to finish? People still want to know what the estimate is. And that's why everyone's irritated with the Crosstown CEO, because even though the project's way behind time, he still won't tell us the new revised date. He's not really, he's not showing us how he's rebaselined the project. I can't figure out why I can't hear. My hearing aid's not in my ear. That's why. So those are the things that you can do. So the other thing that's kind of interesting is this. So here's the formula. And so you can sort of see, again, there's a lot of math if you want to do it. It's not hard math, but it's just kind of thing. But you can sort of look at, obviously, if you are under budget and ahead of schedule, so the perfect green box, that means your ratios for both your cost and your schedule are going to be greater than 1, right? So you're doing much better than you should have. And obviously in the red box, you're behind by both, and vice versa. What the second one shows is that in any given project, it's not necessarily that you're always, once you start a project and you get behind schedule and behind budget into the red zone, that you stay there. So I kind of drew the stars sort of looking at different points in time or milestones, whatever you want to call them. You can sort of see, obviously the project starts in the middle, before you've spent $1, everything's perfect. And then as soon as you start working on the project, we get a little bit behind, and a little bit over budget. Then we catch up a little bit of time, but we're even more over budget. And then it shoots down to being a little bit under budget. So we save some money and get sort of caught up in schedule. So you can sort of see that the schedule can vary over time. You can, basically those 3 lines can crisscross each other depending on different aspects. So some tasks, maybe you forecast more optimistically and others more pessimistically. You can see how this can change. And I'll show you an example of that. But the idea is once you're behind schedule, you're not always stuck there. Things do move around. So here's sort of 2 examples of projects. You can see again, I tried to sort of do some attempt at color coding them. So you can see the black is the plan. So let's talk about the top corner, the top left. So you see the top corner, there's the plan, and there's the actual. So you sort of see, and the green is the cost. So you can sort of see, as you would expect, this one's one where it's behind cost and over budget. But you can sort of see it's continuous, right? So you're always in the same place. Things were going pretty well. And so if you look at the second diagram, you can see that I mark the over budget, under budget line as the orange. And you can see the green is always over budget. So we're always a little bit over. The green line stays above the blue one, so it's always over budget, and it's continuous. It's nice and straight. Same thing for the schedule. If you look at the bottom right corner, again, the gold is the ahead behind sort of line, the SPI of 1. And you can see in this case, again, we're always a little bit behind time, right? So the black line is behind the blue line on the horizontal, right? So we're always behind time. And as we get up to the end, it always finishes at the exact same place, because you have to always finish at 100%, right? So it kind of creeps up, but it's a sort of flat line. So that's how it kind of flows. Unlike Project B, and so you can see Project B, basically, without going into a lot of detail, you can see that the cost and even the plan crisscross, or the earned value and the cost crisscross the plan many different times. And so that's sort of plotted out in this, my effort to recolor the gray line red. And you'll sort of see that at different times, we're over budget, and then for a little while we get under budget, and then we kind of end up sort of back to the same over budget as the original Project A. Same thing, the schedule. We are sort of behind schedule, and then for a little while we catch up and we become ahead of schedule, but then we kind of lose that and we end up back at the sort of same place. So just sort of an illustration, sort of mathematically or diagrammatically, I guess, more than math, showing that you can, the lines can crisscross potentially. It's more likely that they're generally a little bit more stable like Project A, but that certainly can happen like B, where you can be ahead and behind schedule depending on different tasks, right? So it can be sort of at any given time, you can see that they're lined up. So at any given time, if you look at the peak of the schedule SPI, you can see that the earned value, the blue line, is much higher than the black one, and so that's why it's ahead of schedule, right? If you drew the vertical this way or the horizontal, more likely the horizontal, you'd see that the blue line is ahead of the black line, so that means we're ahead of schedule, which is why there's a little peak there. So take a look at that when you have time. You'll sort of see that this does make sense without getting into all the math. I'm trying to make it as visual as possible. So you can see two things though that we did here. So the first is that we finished both projects over budget. So you can sort of see they spent the budget was only 85% of the original, so that's the finish point. And the other one, so so in the first one, the cost and the earned value always have to be in the same uh, vertical, which was what I told you before. And in the schedule one, the earned value and the schedule, the earned value and the earned value and the plan have to be on the same horizontal, right? So that's why they end up in the same place at the on the bar. So the PV and the EV have to be the same at the end, and the account and the EV have to be the same. So that's just the four different kind of squares, how they work out. Okay, so here's just a picture of baselining. So here's the sort of same sort of diagram that we have, and you can see that we're in I guess September, and you can see that that's the data date, and you can see where the EV is and the PV, so the plan value and the actual cost, right? And so that's where we are at that point in time, and you can sort of see how those forecast out with the little dotted lines where they're sort of going, and you can see that we're going to be behind schedule and over cost as the sort of typical example. But what rebaselining does is you sort of pretend that all that stuff is past, and so you build a new baseline, this PV2, and you basically build it off the current spending because the current spending's been spent, it's sunk. So you sort of say, okay, in September we've already spent this much money. Let's plan out how much money we're going to spend from here on in, and so you start planning from there on, and see where that goes. So that's the new baseline. So that's you sort of reset all the calculations, right? And then you sort of say that's the new plan, and now we'll track against that new plan and see where we end up, right? And so if you look at the EV, it's going to end up at the same time as the plan, right? And the costs, if the costs stay the same, they will end up there too. So we'll end up with a new plan that's accurate if that's what we're playing. So that rebaselining just means you're basically shifting the plan on top of the curve that you think it's going to be going forward onto the current costs. So you just kind of shift the curve up and say, okay, we're replanning the exercise. And so again, just to illustrate that, go back to Sydney. Here's our plan. And I looked forever and ever to try to find, if anyone ever finds this, I'd love to know. But let's say that because there's no indication that they rebaseline, but it's not something that they would write about anyways. Like, this is for project management geeks like me and now you. But I made a model of if they did rebaseline just once, and so here's what the thing is. So you can sort of see at year 4, they had this plan and it didn't look very good. So what they did was they sort of rebaselined it so that they have a new PV and a new EV, which is the green and the yellow. And you can see that even with the same cost spendings, they've moved that up, and you end up with still a bad project, but one that's 1.7 times over budget and 1.3 times over time, as opposed to the 14 times and the over budget and 3.5, because they've reset the thing at that 4-year mark. You can see that they've come up. The green is sort of the new plan. It's extended because the old plan actually even ended at 4 years. So they've extended the new plan to whatever, 9 or 10 years. And the new EV, the dotted yellow, also extended to the new sort of date. And so that's what rebaselining would have done. It would have sort of showed, yes, we're still, we have a new plan, which is like 9 years and whatever, $60 million, and we didn't quite get there either, but at least it's closer to the truth, right? There's no point, obviously, if you've only planned it 4 years and now it's 4.5 years time to use the old graph, because it's just doesn't show you anything anymore. So, the costs to up to the 4 years are sunk no matter what's been spent and no matter what's been done. So it's a good time to re-baseline and plan going forward. This is just another version showing all sorts of the different kinds of definitions and things like that. And so what it sort of shows at the top is you have this management reserve, and you can actually keep changing the final estimated, the budget as you go along, as you're refinancing. But again, it's just more of the definitions that we've already talked about. So one more thing is, and I've never seen this, so it's kind of a little bit odd, but there is this concept that if you did your, if the tasks are not entirely dependent, there's a little bit of interdependency, or you can start on some before others are finished. You could get into the situation like Project B, where you have more tasks but partially done, and so you end up getting kind of a distorted calculation. So they call that the P factor. And so if the P factor is high, which means you're sort of counting the tasks that are getting done in the proper order, that's the normal way. But once in a while, I just put this in because there's a kind of a weird a phenomena that could happen if people are sort of taking credit for parts of tasks going on in the future that aren't really on the thing. You can get a sort of distorted a curve to make it look like you've earned more than you really have. So you have to just beware of that P factor kind of thing. But again, it's a very strange little anomaly. One other strange thing that I have here is this. Obviously, when we talk about PERTs and triangular distributions, obviously you could theoretically, the blue again is the plan, but you theoretically could have three different cost estimates, sort of a high, medium, low, and you could have three different schedule estimates. So sort of the green, optimistic, pessimistic, and ideal. And in this case, of course, you can see that this is a good project. It's under cost and ahead of schedule, but you can sort of see you could draw multiple curves based on the different sort of variables in your sort of distribution. So again, you could get into lots of crazy math, and I don't know what all the Z equals CO minus CE means, but I'm sure it's all related to the same kind of calculations of all those EVM things, but I didn't get into all this. But it just to basically show you could forecast multiple scenarios. So you want to say, in the best case, we're going to be finished in 12 months. In the worst case, we're going to be finished in 14 months. So people can have that kind of range if you want to get into some serious kind of, and you can sort of say, we're going to finish between, $7 million and $1 billion, right? Depending on these different numbers. So again, if you have tons and tons of data, you can obviously crunch and graph them thousands of different ways. And this is just sort of an example of that. Does that all make sense? That's sort of all the EVM we're going to do. Well, no, that's not true. We always got more. But that's what we're going to do. So what I want to really, where this is all leading, and hopefully this will help, is this. So there's a project management simulation, and in actual fact, it gets graded, and it will go live at 9 o'clock tonight. And I would encourage all of you to log on in the next day or so, because I'm around. So if there's any problems, you can email me. Obviously you can email me on the weekend too, but I'm just slower at answering. But to make sure that it's working and running. But basically there are 8 scenarios, and you should do each one a couple of times. Basically, it's sort of like an earned value diagram. You can see the 2 diagrams here before. It sort of shows the plan schedule in red and the actual schedule in blue, and in the other case, the plan budget in red and the actual budget in blue. So it's not an actual EVM exactly. Unfortunately, the simulation doesn't do it exactly like that, but it sort of shows. And what it allows you to do is go in and pick the number of people that you want to have working, the number of days, the number of meetings, the number of prototypes. And by all doing this, these scores kind of generally get calculated, right? And you can sort of see in this case, these people were way ahead of schedule, but way over budget, which is certainly one way to do it, right? You spend a ton of money, you can kind of get ahead. They spent a lot of money on experts, and they had a lot of meetings and things like that. So they blew the budget, but they did get finished ahead of schedule, right? So in this particular case, they got a score of 724 points. So the thing has some sort of scoring system. So this is what I want you to do. You know, it's kind of fun. And the first couple of times you just enter some numbers, see what happens. Don't worry about it. And then kind of as you kind of go through the scenarios, you can play each one about 5 or 6 times. I think I said it, but you don't only have to do it a couple of times. But go through the different scenarios and try to see if you can, you know, just use your sort of common sense to try to come out with a high score. Basically, there'll be a prize for the highest score. There'll be a prize for the person who does the most simulations, just to encourage everyone to do that. And I give a grade, but a grade is sort of much more for effort than it is for really you know, any particular result or anything. I mean, some people do that where they say, okay, the highest person will get 10 out of 10, and then we'll scale it from there. I don't do that kind of stuff, but just sort of for effort. But try the simulation. It costs what did it cost? It costs the university Canadian $25 a person actually to buy this. So I got approval for this. I spent $501 today. I've done it in all 3 of my previous classes, and it's kind of fun. And some people really get into it and kind of play with there's lots and lots of different variables. But if you have any questions, you can email me or do a Zoom and try that. But just try it a few times. The first time people usually score about 150 or something. They end up being way behind schedule, way over budget because they've kind of blown all the resources. And then you start learning how to kind of manage all the issues. You get these little happy face warnings to say, you know, your employees are very upset because you're underpaying them, and so you have to kind of increase the budget. Or you get once in a while it actually just shuts down and says your people have quit, you're done, and it just cancels the thing. So it's kind of funny. And as you get into the later scenarios, once in a while disasters happen. So it suddenly says, you know, the main production line that you're using has broken now. So, you know, there's no production for the next 2 weeks. And so obviously, you know, your schedule goes to kablooey. But it's kind of fun to try this. But it's not really quite earned value management, but it's very related to that, sort of fiddling with these 2 major components, which is time and schedule, and looking at various components to make it work. So give that a try. I get to monitor this, and I can post all the results. So next week we'll have a little rogues gallery of the people who did the best, the people who did the worst, all these kinds of things. But give that a try, and I will we can sort of just try that. So in module 7, which is this week, at the very end, it shows you there's a little pre-read sort of thing for it, and it also has the link to get into this program and run it. You have to just log in with your name or something, and so it counts the number of people who've gone on and make sure that I have paid enough money for everyone to play. But it is kind of fun, and you can sort of try all sorts of different things. I think this is one of the higher scores, but you can sort of see it sort of has, you know, scope rating, you know, achieving the goals and exceeding the goals, and for achieving the resources and things like that. So you get little points for different things as it rolls up. So give that a try. Send me an email if there's any issues, or a text, and I will try to resolve them. I will monitor some of this. I will also play it because it's kind of fun, and we'll see how that all goes. So that's, you know, try to do that in the next week. If it takes a little bit longer, we'll do that, but hopefully we can get this by next week. Some people played some of it. It's open. I think you have your subscription will go till, I think, January. I think it's 6 months, so you have till January to do this. But so if you want to go back to it again and play later, you can. But give that a try. There's all kinds of variables that you can try. So here's another thing that I just sort of drew again, another sort of process. So I just drew some of these. These are in my little chapter that I wrote. But what I did was I sort of created this idea of making this sort of final box. And so here's sort of the box. So the first one shows sort of the box um, at 6 months. So this project's probably it's planned for 7 months. You can see the green line goes out to 7. So it's 6 months. This is where the actual cost is and the earned value. And you can sort of see that you can draw a box between the earned value, the EV, and the AC. So the cost, the the plan and the schedule, and you end up with a box. And this little box, then you can kind of measure the things. And so what this box shows is that you are unfavorable $535 dollars or thousands of dollars, whichever the units are. And you're also 1.24 years unfavorable behind schedule. So you can see that that's because the EV is lower than both the other curves. So obviously both things are going to be bad. And then you can see that I then forecast out in the bottom right one, you forecast out those things. I just made some random forecasts. And so you sort of see you generate a new box, right? So the plan never changes because that was the original plan. We didn't re-baseline or anything. And you can see where we finished with the EV and we finished with the budget. And you can sort of see now we're 2 years unfavorable and we're $950,000 unfavorable, which makes some sort of sense that, if we're already behind in both time and money, if we continue on with relatively linear lines, we're going to end up more behind and more over budget, right? So this idea of creating these little general boxes, either in process or at the end or both, gives you some idea of where we're going. So I also did this for rocks and bands. So rocks and bands. So the first picture on the top is the base. So that's the 12 weeks. And then the other one is the sort of the good solution, which was done in 9 weeks. And so you can see if you plot these two, and I took all the data from these and plotted them, you can see that what's happening is the plan value is the green, the actual cost is the red, and the earned value is the blue. And we ended up with exactly as the calculations show. And I didn't fake this. I actually plotted. You can see I plotted every single number. Then we end up 3 weeks favorable because we did it 9 instead of 12, but we did it with $1,200 more, which is what it shows there, right? So this actually gives you an idea of what you could see in a curve when you crash a schedule. So that we did move the time back. So you can see the earned value is before the plan value on the horizontal axis, but the actual cost is higher than the earned value on the vertical axis. So that's why there's an increase in expenditure. So just kind of taking a real example that we've already done and kind of trying to show an earned value diagram on it. And obviously anywhere like at month 5 or 6, or week 5, it's actually weeks. In week 5, you could draw the box there and show that you're a little bit over cost, but a little bit ahead of schedule. You could draw the same kind of squares anywhere on that whole sheet and compare it to the plan. And then I think I did Rachel's just because hers is always impressive. And so you can see again, you can see hopefully that the plan value stays the same, right? So see when I flick between curves, it doesn't change because the plan value was the original 12 weeks that came with the scenario. So here in Rachel's amazing crash, she actually saves 4 weeks. She gets it done in 8, but it costs $1,600 more. So you can see again how the actual cost is higher than the earned value, but the time is much better than the plan value, right? So again, showing you how these can predict what happened, right? That this is kind of what you would do. So if you were going along and you realized, well, in this case, in the scenario that we do, we basically assume that at point 0, you're in trouble. So obviously we spend more, we put more resources on it, and as a result, we get ahead of schedule and get it done into 4 weeks earlier at actually a little bit higher cost. Well, significant cost more, right? So, sort of this is a 21% increase in cost for a 33% time reduction. And that's what that little box basically shows. So take a look at that and think about how we did this back at week 2. So here's just a couple of quotes on compound interest and things like that from some of our famous friends. Warren Buffett, the Oracle of Omaha. Ben Franklin, I don't know, one of the uh, founders of the US, and of course, Albert Einstein. So they're all sort of saying the same sort of thing. I like Einstein's, compound interest is the 8th wonder of the world. And you've all sort of heard about the value of compounding, right? Of compound interest, right? What they tell you, although it's not very lots of times they tell you these great things that are true but difficult to do. They sort of say, at a young age like you are at, you guys should be putting away money, and then it'll grow compound and you'll be wealthy as can be by the time you get to be as age as me. But the problem is, yeah, putting away money is a little tough when you when you don't have much and you've got all the expenses. So it's a good theory, but it doesn't really work, right? But that's the idea of compound interest, right? So we're just going to go into a little bit of that. So this is sort of you've seen these before. These are compound interest curves. And so you can sort of see, this is sort of present value type calculations, and we're going to, leads to, I just put a little bit in just to kind of remind you, because one of the things that I think that I like to teach is really on the next slide, talking about just calculating growth rates. Like, people are always asking you what the growth rate is of something. And so it's always nice to know. And so I'll show you that in the next slide. So you've all seen these curves, right? So here's the thing, and you really don't have to, you can read all this. This is basically it's all the derivation of it, but really the bottom thing is, look at the green dot. This is all you have to remember, is that the interest rate or the growth rate is the final value divided by the initial value to the 1 over the number of periods. And then you have to minus 100 to get it right. So if someone says that, Disney is now worth $6 million and it was worth $1 million 5 years ago, that would be 6 over 1, which is 6 to the 1/5 power. So if you have a calculator that's good enough to do that, which I happen to on my phone, not everyone does, but I do these kind of calculations all the time. You can calculate the compound growth rate. So that's the little formula. If you memorize that, don't worry about how it was derived. You can look through all the logs if you want, but this is what I do in my spare time, like a nerd that I am. 6 enter 0.2 to the power, which is 1/5, is a growth rate of 43% per year. So it comes out to 1.43, but if you minus 1 from it, you end up 43%. So this is how you can figure out, or your parents can figure out, what they're earning on their house. I figure my house is worth, $2 million, and I paid $500,000. So that's 4 times, the ratio is 4, but over 30 years, let me see what that would be just for fun. 4 enter 30, 1 over to the power. Yeah, it's about 5% return annually, which is probably what housing real estate does on average over the long term, right? Not on the thing. So on the other side, just gives you a few little things. So if something doubles in every 10 years, that's about an interest rate of about 7%. If something doubles in 5 years, it's about 15%. So those are kind of just sort of rules of thumb. I always remember the 10 years, 7%. So someone says it doubled in 10 years, that's about a 7% annual interest rate, or even if it's the reverse. But that's just to sort of remember something. So anytime you're doing any kind of calculation, you're in some other class and they're sort of saying, what's sort of the growth rate of the number of students at U of T or anything else, you can say, well, now there's 80,000 and there were only 10,000 20 years ago. You can do 80 divided by 10 to 1 over the 20 years, and you'll get that kind of growth rate and say it was the average growth rate. The average annual growth rate was 6% or 7%, whatever it was, right? So it's a good way to, a lot of times that comes up. People want to know what growth rates are. When you're talking about business and you're talking about, how well a product's going to do, you want to sort of know what's the growth rate of, Apple iPhones. You say, 50 years ago, they sold 1,000 and now they sell 1 million. do the math and say, yeah, it's growing at 12% a year. And so you can compare that 12% growth rate to Samsung that's only growing at 5% or whatever you want to compare. So this is kind of a way to do those kind of calculations, useful for lots of assignments and things. Okay, so we're on the backside here on the finish line, chapter 14, which is the chapter 13 and 14, actually, funny enough, are the two that got soaked in my flood in my basement. So I had to kind of pull the pages apart nicely. Luckily, almost everything that I got wet seems to pull apart relatively well. A couple of, I think my car insurance is turned into paper mache and is no good, but most everything else kind of survived. But anyways, so project termination is sort of the last phase of a project, and it's a really important phase in a project as well. And basically, the first quote is kind of an interesting one that was in Pinto that sort of, or somewhere else. I can't remember where I found it, but termination of a project is a project in itself. So closing up and getting it all finished and packed is really good. And the thing, remember, when our first definition of a project is something that has a fixed amount of time and then it ends. So they call that extinction. So basically, it doesn't matter if the project ends successfully or unsuccessfully, or if you just stop it and say, okay, that's it. Like I did in some of my investments, and just say, okay, that's it. We're not putting any more money in. Let's just shut this thing down. It doesn't matter how a project ends. It does end. And so you have to, it needs to be wrapped up. Certainly when you shut down a company, you have to pay, any back wages that you owe, things like that. You want to clean up things. I made sure that none of my 6 companies, well, how many went under? One, I guess we shut down one. Can't remember. We only shut down one, I guess, but I made sure it didn't go bankrupt. I didn't want to bankrupt it. I didn't want that kind of reputation. I paid off all my bills, made deals with the bank to sort of say, we'll pay you off as soon as we can, and shut it down in a kind of a nice way. Actually we shut down 2, and then we paid severance to our employees, even though we don't have to by law. But I sort of, as the company's starting to fail, then it only makes sense to say, how much money do we have left? If we had to pay severance, how much would that be? And then say, okay, then we have to shut it down today because we only have enough money to pay out. So we paid out our 2 or 3 technicians, sort of a month per year that they worked, or whatever the government said we should pay, the general rules for severance should be. We paid back salary, anything that they actually earned. And so we made the company shut down nicely. So projects terminate no matter whether or not it's successful or unsuccessful, whichever way you want to do that. So that's kind of how you have to close it down. And the worst thing is that can happen for projects, as it says here, the last line is this sort of idea of starvation, where companies, where you don't actually, projects are hard to cancel because there's always someone kind of saying, well, what if this happened? We don't want to, it's sort of this sunk cost fallacy. People don't want to walk away and say it's dead. They sort of say, well, maybe there's maybe a little chance it can happen. So things become little pet projects and sort of secret little projects that are sort of still bumping along, spending a little bit of money. That's the worst, but it does happen. And so you have to watch out for that kind of thing. Sort of, if you're going to cancel a project, cancel. But I mean, I had this problem with patents. We had some patents that we were not going to use at Sanofi ever. I talked to the inventors. I talked to everybody. They were, patent lasts for 20 years, as some of you may know. And these patents they were sort of 16, 17 years old. And I said to people, we're not going to use this next 3 years. We couldn't even get a product in the market in 3 years. So there's no way we're using this. Let's just shut this down and save the patent fees for 3 years. We had a whole pile of them. I said, we've saved, $50,000, $100,000 a year if we just shut down some of these, the obvious ones, not even the kind of marginal ones. No one wanted to do it. So they kind of just like this, they sort of just kind of lived on and burned a little bit of money. And we just, it was very frustrating because I thought, geez, I can save more money than I'm earning here just by shutting down a few little silly patents. But no one could sort of let it go. They had this sunk cost kind of mindset that, what if suddenly it became worth thing? I don't want to be the one who said get rid of it when it suddenly reappeared from the dead, right? And there's always a story about something that did reappear from the dead, so that it kind of keeps everyone else worried that, you know, we have to keep these things kind of going. So canceling projects, finishing projects, very difficult. When we, you know, most of them in early stage and startup, my venture capital experience is mostly when the venture capital says we're not funding it anymore, it does die because there's no money. So it kind of, you know, it's sort of a forced death, but one would hope that most projects end because you meet with the team and the investors and everybody else and say, you know, we gave that a good try, but you know, the odds of it working are just not there. Let's step away. Kind of what Joe Biden did, one would say, you know, sort of say, we looked at this, we're giving it a good try, but you know, it's time to stop that, you know, cancel this project and move on to a better project. Well, hopefully he's done. He's actually speaking tonight, so it'll be interesting to see what he says, but I'm sure he'll thank everyone for supporting him and, you know, explain why it was a tough decision, but we'll see. So the closeout process, I think this was on the quick write, but basically, you know, finishing the work is the hardest thing. It's a really challenge to clean up, right? It's kind of like I relate this to sort of like cooking, right? It's really fun to cook maybe, but the cleaning up part is not as much fun. So, you know, my daughter is maybe the worst. When she finishes cooking, the place looks like a bomb went off. There's flour everywhere and everything else all over the place because she doesn't mind the work part, but the cleanup part she doesn't like. So I end up being the cleanup guy usually. I'm usually a cleanup guy for painting too. I'm not allowed to paint too much, but I'm allowed to clean the brushes at the end. But that's the whole sort of the motivation to do the cleaning after you've kind of mostly finished the project is generally low. Um, Passing the project over. So if you've been working on this project for a long time, and then it's going to become part of a process, a normal sort of part of the system. That's also important too. That big mistake that people make for a lot of projects, software projects especially, is they don't train anyone. So they kind of write this great piece of software that does all these fantastic things. It's very successful. Let's say it all works, but then they forget to train everyone, and they don't realize that, you know, the people who didn't design it don't really know how to use it nearly like you do, who were doing it day in, day out, right? So the really important part is to make sure that you train the things and you write. Again, it's another motivational problem. Writing up manuals on how to use stuff is not nearly as much fun as writing the code in the first place, right? So people kind of going, oh, I really have to write a manual, and you know, obviously, you know, gaining acceptance and make sure people really like it, but that you should have been doing the whole time. But it's something that needs to be done at the end, that the client or customer is happy. You know, lessons learned is really important. You know, full documentation and making sure you paid all your bills and cleaned up everything, you know, sort of the end of a process is important too. And then obviously, really important is really disbanding the team. And that's important because, you know, these people have been working hard for a couple of years, and now kind of in theory they have nothing to do. And so you want to make sure that the organization has sort of got roles for them to move into, or at least is sort of saying, you know, don't worry, you know, you're a good project manager, a good project team member. We're gonna, you know, there are many other projects in the company. We're gonna shift you around and find a place for you to go. So, you know, otherwise you have some incentive to kind of keep the project running forever, right? So you won't be displaced. So you have to really, good companies really manage their project teams carefully to make sure that people don't feel sort of isolated and disillusioned and, you know, leave the company and things like that. Or worse, if the company says, well, we don't have anything for you, so we got to get rid of you. That's not really, you know, the thing you want in a project. You really want to be able to find places for those team members to move on to other projects, right? So that's really an important part of sort of disbanding the team, trying to find other places for them to go. And sometimes companies do even outplace people out of the company. They do not fit, but then they spend good companies will spend a fair amount of money helping you with outside groups who look for new positions for you and give you, you know, resume training and all the other sorts of stuff. I've been through that, at least to kind of smooth that transition. But if you're on a team that you know that when the project's over, you're going to get canned, it's just kind of demotivates the whole project. So it's really, really important to manage your team. going forward. So here's just another form, sort of a kind of a summary closeout report. Again, just an example. There's lots of these things, these different tools that can be used for, whatever, whichever way you want. But here's just kind of another form set that I just found, listing sort of who was involved and what was delivered and the expenses, and really most important, and it would never fit on a form this small, but sort of the lessons learned, and that's really what I want to see, something like this for your major project, sort of, what you did. And certainly from the ones I've read so far, they all look really interesting. But, sort of what you've done, who was involved, to some extent expenses if you had them, and the schedule. And then really the sort of most important thing that I sort of quote unquote grade is really the sort of lessons learned. What did you sort of extract from that? And people had some interesting lessons already, a lot on sort of communication, which is often a big case, or a big issue is what did we learn about trying to communicate to different people and make it clear, right? So that's an important aspect of the sort of final report. So it really, the reason I try to get you to do real projects is so that that you have real lessons that fall out of them that you do. The other thing too that I'd like to see, and I mentioned that in a couple of the reports that I'm halfway marking is, or at least reading, is are you using some of these project management tools? Should you? Are you going to try some of them? I'm not necessarily promoting EVM because it's a little complicated, but even Gantt charts and stuff, are people using some of them? Some groups are, some maybe aren't, some are maybe using Asana or Monday or some of the other tools, but whatever, it's just interesting to learn about which tools you're using, which ones work. Are you just using Excel? Are you just using email? Are there, what are the pros and cons of all these different sort of tools? And could it have been better with some of the other things? So those are all the different sort of aspects of sort of the major project, and just basically closing out a project, because that's effectively, even though your project might not be done by the time that the due date for our assignment, we need a kind of a progress report, closeout report, whatever you want to call it. It's kind of a blend of the two at that time anyways. I know some people's projects go on much longer, some will be done by then. So I see we're a little bit ahead of time tonight. That's nice. What could happen? This is the last quick write. What could happen with a poor closeout? We'll give you a minute or so for that one. Okay, 3, 2, 1. Good. These are excellent. So unresolved issues, lost records, for sure. I mean, there's so much sort of corporate learning that people lose. They notice it most when someone leaves. So we actually, there was this guy who was a good friend of mine who had been with the company, I think since he was like 14. So he'd been there like, I don't know, he was 100 years old. I don't know how old he was, but he'd been there for 60 years, and they actually called him back on a consulting contract after he'd retired, and they paid him very well to basically tell him where this particular pipe was buried, because no one had any records of this pipe, and they were going to dig up the driveway, and they were afraid that they were going to hit this thing, and so they needed someone who actually had been around way back then to figure out what was going on. It was hilarious, but we had a nice lunch with the guy when he popped in for his 20-minute piece of consulting and said it was right there. That's where they buried it. But that's the kind of thing that records get lost, people get forgot, and obviously if you have legal issues and stuff like that, it can even be worse. So that's all important. So debts obviously impacts, so things like that, lessons learned, you sort of losing sort of corporate knowledge and experience, of course, and there's more efforts now with sort of knowledge management, trying to keep some of this sort of expertise and knowledge in there. Sort of, what else? Financial risk, poor knowledge transfer. They mentioned these sort of legal compliance. We got that. So all those sort of things. So that's good. You guys all got those kind of answers. So there's all sorts of things that can happen. So it really is important, even though it seems like it's kind of boring because it's sort of the after the project, right? Project, they sort of go, oh yeah, you have to do this. I mean, the other example I have is my brother tends to he does events management, so he tends to work for things like he worked for the Canada Games, he worked for the Pan Am Games, and again, the same sort of thing with this disbanding the team. Those people all are looking for their next job, and they know that, like, say you're working for the Paris Olympics right now, you know that on August, whatever the date is, 20th, you'll be laid off. The Olympics are over. You'll be done. Maybe you stay on for a week to clean up and put the volleyball back in the bag and things like that, or a month. But after that, it's over. And so you don't have a thing. So what do these people do? About now, even before the Olympics start, they start looking for the next job. They're looking for the next event somewhere, the next Olympics, the next sailing race, the next world, bike race, the Tour de France, whatever. And lots of them the senior people tend to quit before the event even happens. So all this expertise is lost because they know there's nothing after it, right? So there's not this nice continuous flow. And so people are saying, well, geez, I got to jump ship. So they try to put in bonuses and stuff to say, if you stay to the end, you get a bonus. I think that for the Canada Games, my brother got a 5% bonus for staying to the end. And kind of going, 5% is not very much when you're looking for your next job somewhere else. Like, you got to make it much more serious. So there's a big flaw in some of these projects, so that they don't take care of the people properly, so that that information and that expertise gets lost even before the games start. A lot of people quit before the games start. They've done all the planning for the last 2 years, and then they quit just before or during, because that's when the next position comes up to, do the 2 years pre-planning for the Tour de France or for the next Olympics or something else. So it's kind of a crazy situation. So I think those are all good closeouts. So here's just another sort of last sort of slide about the sort of learnings and lesson capture. Obviously, you can learn before. You can sort of seek, at the bottom here, you can sort of have peer assistance and talk to people who are project managers and say, and think, and even brainstorm, what are the major sort of risks that we might come up with, and what are the sort of issues in forecasting, what are the most difficult things to forecast, what are sort of strategic resources that we need to get our hands on before we start, what kind of order. Those kinds of things can obviously be learned before, to some extent, from people who've done it before. Often you start off in your sort of project career working with other people who have more experience, and you kind of learn on the fly as you're going. So that's kind of the peer assistance. Then you obviously can learn during things happen. You can kind of, you like me, I can tell stories forever and ever about all kinds of weird things that happened, during processes that I thought were in control, but turned out to not be in such control. So there's always learning to do. And then obviously the sort of learning afterwards, right? So the review of the whole project and looking at it kind of the big picture, and say, why did we miss by 14 times the budget and 3.5 times the time from the original one? Yeah, so we did better when we replanned, but we had to replan because we didn't take into account lots of things that we should have, right? So I mean, I read one of the reports right now was on that Curuana City. This is a city that they're moving. You've read the case probably, but city they're moving because it's sitting on top of a mine. They have to move it somewhere else. It's taken them 35 years to move it. You're kind of going, I know it's a big project, but 35 years seems like that's half a lifetime, right? Like this is it seems like a very long project, and you kind of wonder if that is actually makes sense, or should they spend twice as much money and get it done in, 10, right? But whatever, 35 years is what the plan is, and maybe they're doing it nice and slow so they don't disrupt anyone. I don't know, but it seems like a 35-year project seems like a long time. Elon Musk doesn't do any 35-year projects, I can tell you that. Um, he's doing 3-year projects, right? And he's cracking the whip and making sure everyone does that. But so, anyways, we can see. But that's the thing. So lesson capture is very important, and actually, it's kind of a side thing that I'm thinking about more and more is sort of how to capture sort of just knowledge management, some stuff that you learn in courses. So obviously, one of them that I am a strong advocate of is sort of experiential learning. So the more that you do kind of games and events and simulations and stuff, it just brings some of that stuff home as opposed to, seeing a slide with 20 formulas on it and saying, try to understand this. So, yeah, EAC equals, AC minus, PV, like whatever. So it's more experiential. That being said, one more pitch for my little book chapter. It's on the website. It takes about an hour. It's program learning. So what it does, it gives you a little information, then asks you a question, and depending on if you answer correctly or incorrectly, it sends you to different places in the book, and it's kind of fun, I think. So anyone who wants to try that, anyone who wants to give me any feedback on that would be greatly appreciated. It's not really necessary for the course, but it goes into EVM in excruciating detail. If you want to explore that a little bit further. But failing that, I will as soon as I get off this Zoom, I will launch the simulation. I'll move it forward to quarter to 9, so it goes immediately. And so if you want to go on tonight, but if not, try to do it as soon as you can, just so that we can see that you've got, you've just played it once, just so that I can see that everyone's kind of logged on and it's kind of working. And then obviously you can do many, many different trials and try it. But I just want to make sure that everything's smooth. The problem always with being the instructor is you don't see quite the same thing as the students do. Same with Quirkus. I sort of see what's going on, but I can't tell exactly if things are working. So it does rely on a little bit of feedback. Every so often, one of you tells me I haven't pushed a button, I haven't launched the particular quiz or something yet. And so those are the kind of things that it's hard for you to see when you're an instructor. So again, with this simulation, which is, I think, really kind of interesting and fun if you get into it, I just want to make sure that I pushed all the right buttons. So someone give it a try, or a couple of you, or all of you, play it a little bit, but we'll go there. Are there any other questions? If not, we're a little bit early. We're about 12 minutes early, which is a record for me, I think. But I could regale you with more stories of my youth, but I'll save you from that. But if not, look at the EVM, just kind of go over the slides and sort of see that you kind of comprehend them. But don't worry about all the details of the calculations unless you really want to do that. And then I do recommend reading my chapter because it goes into it and more. And try the simulation. It's not, like I say, it's not quite EVM, but it basically is, because it's dealing with like cost and schedule, and it obviously you're trying to progress through it. It just doesn't draw the EVM curve. It just sort of says, yes, you're making progress, and it tells you when you're finished, so you've done the project. So it's sort of an EVM without the one curve being drawn. So give that a try. If not, and that next week, I think we're talking about Agile, and another one that I need to write a chapter on, which is critical chain project management, which is again another kind of bizarre an interesting way to look at project management that not too many people use at the moment. Anyways, if that's all, I'll stay on for a few minutes as I should stop the share. I should stop the video, stop the recording.